Good evening to all. I am Jayapriya from Tamil Nadu under guidance of Dr. N. Nitgyapriya ma'am. Today we will explore the basic concept of convolutional neural network and Hidden Markov model, the application and how they compare. This is my index. Next, introduction. Both convolutional neural network and Hidden Markov model are used in machine learning but for different tasks. Convolutional neural network for image processing and Hidden Markov model for sequence like speaks and handwritten analyze. This presentation cover the concept, application and key difference. Next, basic concept of convolutional neural network. Convolutional neural network are inspired by the human visual system, unlike traditional neural network that process entire images as flat inputs. Convolutional neural network preserve spectral relationship by applying filters to extract hierarchical features. The key idea is to detect patterns, example, edges, shapes, structure at different level and use them for classification or recognition. Why convolutional neural network for image processing? A traditional neural network struggle with high dimensional image data. Convolutional neural network reduce the number of parameters through convolutional and pooling operation. They automatically learn important features without manual feature extraction. The image represents the architecture of a convolutional neural network used for image classification. First, the input image of size 36 by 36 pixel. The first operation applied is a convolutional with a convolution components. What is convolution layer? This is the core building block of convolution neural network. It applies filters to an input image, detecting patterns like edges and shapes. Each filter slides over the image and performs element-wise multiplication, producing a future map. This is the mathematical operation of convolution. X is input image, W for filters, B is bias, X dash for the output future maps. Next, what is happening in the image? The matrix on the left, the number represented fickle intensity of an image. The dark blue regions show the part being proceed. The middle matrix is the filter. This is the 3 by 3 filter, a small matrix used to extract features. The next right side matrix for the future map. The sum of multiple values is placed in a new matrix, highlighting important features. The number 16 in the future map is the result of applying the filter to a part of the image. Next, activation function. Activation function most of used for relieve activation function. Activation function is nothing but it replace all negative value with zero while keeping positive values unchanged. Relieve activation function is defined maximum of 0 comma x. See the example. All negative values become a zero. The positive values not changed. um, ReLU function introduced non-linearity helping convolutional neural network learn complex pattern, reduce the vanishing gradient problem, making training faster. Next, pulling layer reduce the dimension of fixture map while preserving keep information, help in making the network invariant to small translation of the input. Maximum pulling select the highest value in a region. See the example. The 4 by 4 image is divided into 2 by 2 region highlighted in the purple color. For each region the maximum value is taken. For example, the first matrix 2 by 2 7 3 8 7, the maximum value is 8. Next, fully connected layer connect exact feature to final output classes, work like a traditional neural network for classification. For example, um, for example, see the picture. Convert a multi-dimensional future map into a 1D vector. Next, Next, Hidden Markov model is a statistical model used to represent system that transition between hidden state over time with observable outcomes that depend on this state. Next, key components of a hidden Markov model consist of five key components that define how a system transition between hidden state and generate observable outputs. The first component is status is represented by capital S. These are the hidden variables of the model, meaning they are not directly observable. The system transition between these state over time. The notation is given by where n is the number of state. Next component for this observation is represented by O. These are the observable outputs generated by the hidden state. Each state produces an observation based on a probability distribution. The rotation is given by where T is the length of the observation sequence. Next component, transition probability matrix, is represented by capital A. The probability of moving from one hidden state to another. Each entry Aij represents the probability of transition from state Si to state Sj. The notation is given by each row sum to 1. Next component, emission probability matrix, is denoted by capital B. The probability of an observation being generated from a given state. Each entry Pij represents the probability of observing simple Oj when in state S. The notation is given by. Next component, initial probability distribution, is defined by pi I. Specify the probability of starting in each state. Each entry pi I represents the probability of starting in state Si. Next, example of Eden Markov model. Just imagine a person inside a room with no windows. They cannot see the weather, but they can guess it based on the friend's activities. If the friend is walking, shopping, or cleaning, we can infer whether it's sunny or rainy. The system has two hidden state. Rainy is S1, sunny is S2. This represent weather condition which are unknown to us. Next, transition probability is arrow between the state. The probability of moving from one state to another. For example, rainy to rain for 40 percentage, rainy to sunny for 60 percentage, sunny to sunny for 80 percentage, sunny to rainy for 20 percentage. Next, bottom circle in the image, walk, shop, clean for the friend's activity. This is the observation depend on the weather. If rainy, the person is likely to shop 40 percentage. If sunny, the person is likely to walk 60 percentage. Emission probability link from state to observation. This show how likely an observation is given a hidden shade. For example, given it's rainy, the probability of the person walking is 10 percentage, shopping is 40 percentage, cleaning is 50 percentage. Next, how they differ convolutional neural network and Hidden Markov model in terms of data type, processing, architecture, training, strength, and weakness. First, the data type of convolutional neural network work with spectral data, image, video. For example,
Jayapriya,
sir,
you have two minutes more only. Huh?
sir,
You have 2 minutes more only.
okay, sir, okay. For example, recognition face in photos. But Eden Markov model work with spectral data. For example, predicting the next word in speech recognition. Processing for convolutional neural network use filter to detect pattern like edges and gesture. But Eden Markov model use probability to model sequence assuming the next state depend on the previous state. Next, architecture of convolutional neural network as convolution layer, pulling layer, fully connected layer. But Eden Markov model, hidden state, transition probability, emission probability. Training of a convolutional neural network use back propagation and gradient descent for large data. But Eden Markov models use probability based method like Baum-Wells theorem used for small data. Next is strength of convolutional neural network. Extract architecture feature highly accurate, but Eden Morgo effective for sequence modeling and prediction. Weakness of CNN need a lot of labeled data computational efficiency, but Eden Morgo model assume fixed probability struggles with complex patterns. This is our my application for convolution neural network. For image classification, medical imaging, diagnosis, autonomous vehicles, natural language processing. This is my Eden Morgo model application for real life speech recognition, handwriting, and financial. Next, weather, climate prediction. Finally, conclusion. Uh, Convolutional neural network and Eden Morgan model are fundamental model in machine learning. Each suited for different type of data. CNN actually spectral feature extracting, making them indexable for image and pattern recognition. Eden Morgan model are ideal for sequence data, allow effective model of speech, handwriting, and time series pattern. Understanding the difference and application enable better decision making when choosing the right model of AI driven solution. Thank you. Thank you, sir.